have any questions. Okay. We're given a function denoted by g of x, and that is x cubed, and for x less than or equal to 1, and it's 3x minus 2 for x greater than 1. In part A, we're asked to study what happens at x equals 1. So is the function continuous at x equals 1? That is the question. I don't know, but I know the definition of continuity at the point. And that is limit as x approaches 1 from the left. 1 from the left is from x cubed. I don't know, question mark, I don't know if it equals limit as x approaches 1 from the right from 3x minus 2. I don't know if it equals f of 1. Okay? So can anyone give us this limit? Can anyone give us this limit? And can anyone give us f of 1? Anyone? Okay, this limit is 1. This limit is 1. And the function of value at 1 is 1. Therefore, we will conclude that this function is continuous at 1. So, continuous at x equals 1. Part B. Is g differentiable at x equals 1? Why or why not? G of x exists at x equals 1? I don't know. Okay. So what can we do in the situation? We're going to try to find g prime. For x cubed, when we look at x cubed, so we are trying to find x cubed prime, and then I'm trying to find 3x minus 2 prime. And then I'll put them here, and then see what happens. And then I'll discuss more details after we finish that. At this point in time, I do not know differentiation rules. We will. That's our next step after this problem. But for now, I only have the definition of derivative. So I'm going to use it for this. So f prime of x equals the limit of when h approaches 0 from x plus h to the third minus x to the third divided by h. This is the limit of the difference quotient, f of x plus h minus f of x divided by h. So limit as h approaches 0. Now, we have two options here. We either expand this and then subtract x cubed, or we use the difference of cubes and factor. Which route would you like me to go? I can factor. That's one option. And the other option is expand x plus h to the third. Which one would you prefer? Factor the difference of cubes or expand x plus h to the third power? We have to choose. Say it again.
But like, if you expand it by the cube, would it take longer?
Yes, it will take longer, but I was going to trick you on that, and I would have given you the formula directly. You caught me. Yes, it will take longer, but I will give it a shortcut. So, in order to find this, I have to find this, and then multiply and distribute to x plus h. And then do the algebra. But the answer is x cubed plus 3x squared h plus 3x h squared plus h to the third. So I was going to let you do that, multiply and see that you get this. Of course you will. So let's do the factoring then. Let me refresh our memory on factoring as well. And I can put it in. It doesn't matter. But let me just refresh our memory. When you, it can be plus or minus, it doesn't matter. So when you factor the difference of cubes, you will have a minus b and a squared plus ab plus b squared. And if we indeed have plus here, then this is plus and this is minus. This is always positive, we don't even talk about it. So that's the other option, one or the other. So since I already have it here, I'm just going to put it in, and that will be x cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed, everything divided by h. We know that all terms, we discussed that, two things must happen. All terms without h must go away, and they do. And then eventually this h must go away. Of course it will go away because I will factor out h from the top. So this is limit as h approaches 0, h outside, h in the denominator, they go away. So this is 3x squared plus 3xh plus h squared. So the limit of this approaches 0 because h approaches 0. This approaches 0 because h approaches 0. So the answer is 3x squared. This is very useful for section 1.5. So I will write a note to myself. X cubed prime is basically I bring the power in front and I subtract 1 from the power. And this anticipates the next section anyway. I only finished one piece. I only finished this piece. 3x squared. When x, I cannot write the equal symbol. For now, I will have to write x equals 1 because I don't know anything about 1. I know that the derivative of x cubed is 3x squared for x less than 1. We don't know yet about x equals 1. Can anyone give us the derivative of this function? Is there a way of determining the derivative of this function without any calculations? Yes, it's the slope. What is the slope of this line? Anyone? 3. Good. Perfect. So I have the derivative. Since I wrote a lot of stuff here, I'm going to copy it here. So 3x squared for x less than 1, and 3 for x greater than 1. And now I will identify whether this derivative is continuous. Is this derivative continuous? If the derivative is continuous, the function is differentiable everywhere. If this derivative is not continuous, then the function is not differentiable at 1. I know the derivative for x less than 1 is this, carved in stone. I know the derivative for x greater than 1 is this. Both exist. But I don't know if the function is, the derivative is continuous at 1. No problem. Limit, as x approaches 1 from the left from 3x squared, does this equal limit as x approaches 1 from the right of 3? If you say yes, then I'll put back 1 and say the function is differentiable everywhere. If you say no, I have to leave it alone and I will say g prime does not exist at 1. So what is this and what is this? And if they are equal. Can anyone give us the limit from the left?
Yeah, you said 3.
Very good. And the limit from the right? 3. We go back. I'll put it back in and say, therefore, G is differentiable everywhere or on negative infinity to infinity. Good. Any questions? Any questions? Okay, I think we can move on to 1.5 and 1.6 together. So 1.5 and 1.6, differentiation. Rules. So moving forward, we don't need to use the derivative function, the derivative definition of the derivative. We are going to use the differentiation rules, unless we are forced to use the derivative function, the definition. Okay, we already know one, which is the power rule. X raised to n power prime. We already had an example, n times x to n minus 1. We already know that the square root of x prime is 1 over 2 the square root of x. This we determined last time. Also, if we have a function plus another function, so a sum or a difference of functions, and we differentiate each. Here's another rule. If we have a constant times a function and we differentiate, the constant stays outside if it's a factor, and we multiply by f prime. Two rules that we have to memorize. Like it or not, I don't really like to say that, but we have no choice here. Product rule. So if we have a function multiplied by another function and we want to differentiate this product, please remember it's a sum of two terms. First function prime times the second one plus the first times the second function prime. If your book presents it or you find somewhere else that is g times f prime, that's fine. It doesn't matter. I like to keep it in the form of 1, 2, 1, 2. Function 1 times function 2 is function 1 times function 2 plus function 1 times the function 2 prime. So here the first one is prime, here the second one is prime. This is how I like to memorize it. But you will develop your own style and do whatever you feel comfortable with. I tend to forget if I don't use 1, 2, 1, 2, but it's just a matter of habit, really. It's the same thing. If I write 2 times 1 prime is the same thing, or if I want 2 prime times 1 is still the same thing. One more, and then we'll practice all these. A quotient rule. And for now, before we get to the chain rule, these are all our rules. Okay, so the quotient rule is the same idea, but this time is a quotient. The denominator is not differentiated. The denominator is just squared. The numerator is the same with the product rule, but minus. Identical. I'm going to just copy everything but put minus. So I have f prime g, but minus f g prime. And now I'll tell you, feel free to choose any problem from. And of course, when I differentiate a constant, the rate of change of a constant is non-existent. 0. Okay, on page 145, let's practice all of the above.